So for this warm-up, you need to factor each of the quadratics and then find the roots. So if we look at the first one, what do I know about the signs in the first one? They're different, and then the one's negative, one's positive. So if we look here, a negative 72 can only be created by a positive and a negative number. And then when we look at the middle sign, we know that the bigger of the two is negative. So I'm going to have x minus and x plus. Now I need to factor 72. So 1 and 72. And in this list, the smaller number is positive and the bigger number is negative. Do 1 and 72 create a negative 6? Not even close. So 2 and 36, does that one work? No. 3 and 24? No. 4 and 18? No. 5 doesn't work. 6 and 12? 6 and 12 will create a negative 6, and I know where the signs go. So the 12 is negative and the 6 is positive. So those are factors. What are the roots? 12 and x equals negative 6. Good. Okay. So for this one, if the last sign is positive, what does that tell me? Factors have the same sign. If the middle sign is positive, then they're both plus. So x plus, x plus. Now we factor 60. 1 and 60, does that create a 16? No. 2 and 30? No. 3 and 20? No. 4 and 15? No. 5 and 12? No. 6 and 10? Yes. So it's 6 and 10. Now I need to turn these into roots. X equals negative 6 and negative 10. Okay. What if I had one that looked like this? What's that? This one? No. So this is an x squared graph, which means it can hit the x-axis only twice. Okay? So this number is causing the problems. Everything we've done up to this point was just an x squared. It didn't have, these are called coefficients, and the one in front of the biggest one is always called the leading coefficient. If the leading coefficient is something other than 1, that creates some problems. Now, when we solve this, we want to know, where does this graph equal 0? When is the y value equal to 0? Well, do you see any common factors between the three coefficients? A 3. Now, if I were to divide everything by 3, would the equation still be true? Yes. So I would get x squared minus 4x minus 5 equals 0. Have I changed the graph? Is this graph different from that graph? Yes. So my original graph looks something, I don't know where it hits. We'll figure it out in a second. But wherever it is, when you divide by 3, you make it 4 times wider. Well, sorry, 3 times wider. So it's going to look like this. But notice, the roots didn't change. So I changed the equation, which changes the graph. But because the equation equaled 0, and 0 divided by 3 is still 0, the entire graph changed except for the roots. So we're allowed to do that. You're allowed to divide or multiply by any number you want, as long as all you care about are the roots. Because it's certainly going to change the graph, but it won't change the roots. All right? And then we could factor this, x minus 5, x plus 1. So it actually touches at 5 and at -1. So this graph and this graph have the same roots. Okay? Well, what if I can't divide it out? Turn to the last page of your worksheet. Where did those go? Let me see if I can find you one. When I try to factor this, it's no longer just going to be x and x, because these first terms need to multiply to be 3x squared. So one of them will be a 1 and one of them will be a 3. And then the 6 could be 1 and 6 or 2 and 3. So I have tons of options. I could put the 2 here and the 3 here, or I could put the 6 here and the 1 here, or I could put the 6 there and the 1 there, or I could put the 3 there and the 2 there. And the old method for solving these is just put them in place until you find the right combination that works. Now, what if you had 12x squared minus 4x plus 9? Now I have a 1, a 12, a 2, a 6, a 3, and a 4, a 1 and a 9, and a 3 and a 3. It could take you a long time to guess until you create the right combination. That's how I learned those when I was in high school. Terrible mess. I'll never do that to you. Okay? We're going to do something that's kind of strange, but it's going to eliminate the guesswork entirely. You won't have to guess at all. The way I'm going to teach you is going to be to combine all of the factors of 3 and all of the factors of -6. And this is going to look really weird, but it will work every time. So I'm going to multiply the 3x squared and the 6. So 3x squared, 3x squared times -6 is -18x squared. Now, that takes all of the factors of 3 and all of the factors of 6 and combines them. And now if we can figure out the factors of 18 that add to be -7, that will help us find the answer. So the factors of 18 are 1 and 18, 2 and 9, or 3 and 6. Will one of those create a -7? Well, what are the signs, first of all? They're different, and the bigger one is negative. So this list is plus and this list is minus. Does one of them create a -7? -9 plus 2. Now, notice it's an x squared. So we need to write -9. Well, let's actually do it the other way. No, that's okay. -9x plus 2x. So all I did was multiply the first and the last together, found the factors of that add to be -7x, and it was -9x and 2x. Now I'm going to bring down the beginning and the end of this equation. So 3x squared and a -6. It is a little confusing. But once you get the hang of it, it's really fast, and it totally beats guessing. The old guessing problems were a horrible mess. I mean, you might have to try 12 or 13 possibilities before you figure it out. Now let's look at the two equations. If you look carefully, the original equation and the new equation are exactly the same. The only difference is we took the middle term and we split it into a 2 and a 9. But if you look, this equation equals that equation. One of them is just simplified and the other one is not. So that's your goal, is to take that middle term and break it into two numbers that will perform kind of a funny thing that we're going to do here in a second. So now, I'm going to group the first two terms together and the second set of terms together. In the first group, in those first two terms, do you see any common factors between those two terms? 3 and x. They both have a 3 and they both have an x. So I'm going to grab the 3 and the x and I'm going to pull them out and write 3x. If I divide both of those by 3x, what's left? X minus 3. Does anybody not understand how that worked? So 3 goes into 3 and into 9. X goes into x squared and into x. So by pulling the 3x out, I'm going to divide this by 3x, and I'm going to divide that by 3x. If I divide this by 3x, the 3 and the 3 cancel, and x squared over x is just x. So the only thing left over is x. In the second one, when I divide by 3, 9 divided by 3 is 3, x divided by x is 1, so the only thing left over is a negative 3. Okay? In the second group, what do they share? A 2, a positive 2, and what's left over? Well, 2x over 2 is just x. Negative 6 over 2 is negative 3, and that's what I get. Now notice, this parenthesis is exactly the same as that one. If that happens, you did it correctly. If that didn't happen, then you made a mistake. Okay? So, your first factor is going to be x minus 3. Your second factor is going to be that. 3x plus 2. But that will always happen. And the reason that is, if I look here, does this group share anything that this group has? Well, it shares an x minus 3. So if I pull out an x minus 3, the leftover is 3x plus 2. So all I did was separated this group and that group. And now we set them both equal to 0. So x minus 3 equals 0. What's the root? 3. 3x plus 2 equals 0. So subtract 2. 3x equals negative 2. How do I move the 3? Divide by 3. So my second answer is negative 2 over 3. Now that might seem really confusing, but the second time we do it, it's going to be a lot easier. So write this one down somewhere if you'd like, or you can just pay attention. 2x squared plus 13x plus 6. Can I divide out the 2? No, doesn't work. So we got to do it the long way, which is easier than the other way. Times those together. 12x squared. Now I'm looking for the factors of 12 that add to be 13. 1 and 12. Does that work? Yeah, it works. Good. So 1x plus 1x plus 12x. Is everybody okay so far? Now I bring down the 6 and I bring down the 2x squared. Bring those down. And then I group. So I look at my first group and my second group. What does my first group share? An x. So x times, if I get rid of one of the x's in each term, what's left? 2x plus 1. Now, when I factor the second set, I should get 2x plus 1. If I don't get 2x plus 1, then I made a mistake. So what does the second group share? A 2 would work. If I pulled out a 2, would I get 2x plus 1? No. If I pulled out a 3, would I get 2x plus 1? No. So those are the wrong numbers to pull out. And you always want to pull out the biggest one, by the way. If I pull out a 6, then I get 2x plus 1. So my factors are x plus 6 equals 0, And my second factor is 2x plus 1 equals 0. So here I'm going to subtract 6, and I get x equals negative 6. Down here I subtract 1, and I get 2x equals negative 1. Divide by 2, x is negative 1/2. Okay? What? All right, let's look at a new one. Those numbers are huge. Can I divide out the 24? No, 24 doesn't go into 12. Can I divide something out? I could divide out a 2, and that'll make things a little bit easier. If you forget, it will still work. You'll just be dealing with numbers that are a lot larger. I'm going to divide everything by 2. 12x squared minus 17x plus 6. Okay? So now I multiply these together, and I get 72x squared, and it's positive. What do I know about the signs? They're both negative. Okay? So, factors of 72. Negative 1 and negative 72. Does that work? No. Negative 2 and negative 36. Does that work? No. Negative 3 and negative 24. No. Negative 4 and negative 18. Nope. 5 doesn't work. Negative 6 and negative 12. That doesn't work. Negative 7 and negative 8. That's the one. Everybody see that? Negative 7 and negative 8. Wait. It's negative 8, negative 9. 7 doesn't work. Sorry. I did this problem last period. How about that? Negative 8, negative 9. Apparently my memory's not very good. So negative 8, negative 9 makes negative 17. Don't trust me. I'm not trustworthy. So negative 8x minus 9x. I'm going to bring down the first term and the last term. 12x squared plus 6. Okay? If I group the first two and the last two, what do the first two terms share? 4 and an x. So 4x. If I divide out of 4x, what's left? 3x minus 2. Okay? Does everybody get that? So over here, what do they share? What goes into 9 and into 6? 3. So plus 3. And what's left? Negative 3x plus 2. Is that what I wanted? No, my parentheses don't match. Could I fix it so they will match? Instead of dividing by 3, I could divide by negative 3. If I divide by negative 3, what is the negative 3x going to change into? That will change into plus 3, and this plus 2 would turn into a negative 2, and now it works. So sometimes you need to pull out a negative to make the two parentheses equal each other. So my factors are 4x minus 3 equals 0. Add the 3. 4x equals 3. Divide 4. So one answer is 3/4. For the other one, 3x minus 2 equals 0. I'm going to add 2 and divide by 3. And my second answer is 2/3. Okay? What if I end up with something like this? 4x squared plus 2 x plus 2x plus 1. So let's say that I do the multiplication, I split the terms, I bring down the first term and the last term, and I'm at the grouping stage. Can I pull anything out of that? 2x. So 2x, what's left? 2x plus 1. Can I pull anything out of this? No. Nothing goes into 2 and into 1 except, so this is already 2x plus 1, and they match. Well, what goes here? No, not 0. 1 plus 1. You can always pull out a 1. If I pull a 1 out of here, does that change it? No. If I pull a 1 out of here, does that change it? No. What if it said, what if these were both negative? So I get 2x times 2x plus 1 for my first group. What do the numbers in my second group share? Negative. That's all they share, right? Well, I can't just write a negative. It's got to be negative 1 and then 2x plus 1. So if they don't share anything, pull out a 1 or a negative 1, depending on the problem. Okay? So your assignment is to finish the worksheet from yesterday. You now know everything you need to do that. And then we'll work on a different worksheet tomorrow.